Biographies on the visionary geniuses of our time tend to top bestsellers lists. They're fun reads, but instead of acting as a case study for how to run a successful project, they're more often used as a justification for waddling around in a turtleneck and treating your employees like garbage. Are you sick of short form content on how to manifest success and the morning routines of entrepreneurs? What if project success has less to do with the amount of time a CEO spent picking out their outfit and way more to do with the processes and culture within an organization? In this video, we'll move past the aesthetics of success and explore a tried and true method that embraces failure, acknowledges luck, and equips you with tools to solve problems at any level of any size organization. By the way, if you're here for my takes on AI or the hypothetical problem-solving machine, stick around because while lots of things can be automated, this is the stuff that AI isn't particularly good at yet. I think this is where human operators will remain for a long time. Napoleon Hill spent his entire life trying to identify the common traits of some of the most successful innovators of all time. He claims that with the support of Andrew Carnegie, he gained access to people like Thomas Edison, Henry Ford, J.P. Morgan, and many others. With that sort of access, you'd think he'd be able to pinpoint a common thread and devise a solid formula for innovation. Instead, his books and many watered-down successors in the self-help genre have little nuggets of valuable information, but when they try to put together a unifying theory for success, they end up pontificating about some pseudoscientific theory that these people have a mystical alignment with the universe. That's because there is no unifying theory. There's just a messy pursuit and countless variables that cloud the causal factors. When looking at successful innovators, we have to be aware of the survivorship bias that comes from looking at successful projects and trying to identify common traits retroactively. This bias can lead to false conclusions about what actually contributes to success. In reality, most people fail regardless of what they do, and many successful people are the beneficiaries of luck. What if these people were successful despite a lot of their eccentricities? What if they were in the right place at the right time? For every success story, there are hundreds of people who worked just as hard, made the best decisions based on the best information available, and they failed anyway. Many others achieved success by completely different and less glamorous metrics. Innovation, especially in large organizations, is a team effort, with great ideas coming from every direction. That's why the person at the top can be lauded by some and seen as a complete idiot or monster to others. These people are often treated like they're divinely ordained to their tech fiefdoms. In reality, they're fallible contributors to a messy process, and the best ones to work with know that. So I think at this point we can move past the lionization of these figures. While it's important to recognize that luck and failure play a role in the process, not everything is completely random, and there are things we can learn. Maybe we don't have to promote sociopathic behavior as a reality distortion field, but we can recognize when somebody's able to identify a problem, synthesize it, and facilitate a really solid execution. There is a way to catalyze creativity, reduce risk, and improve your odds of success in a project. This framework focuses on solving real-world problems. Michelangelo believed that the true form of a sculpture was already present within the stone. His job, as he saw it, was to remove the excess material and reveal the masterpiece within. In much the same way, effective problem solvers look at problems as puzzles to be solved, not blank canvases to be filled. They operate as facilitators and curators in the process of uncovering a problem and then assembling a collection of ideas to solve it. Most of us are already familiar with a tried and true process for solving puzzles. Various disciplines within technology companies use different terms, but all of them have a process that stems from the scientific method. I'll give a rapid-fire breakdown and how it translates to tech, and then we'll look at some examples. Observe, identify a problem, and seek to understand its full scope. What is a user trying to accomplish? Question. Here you synthesize the problem into something that can be clearly articulated and investigated empirically. What are we trying to learn? Hypothesize. Develop a testable and falsifiable hypothesis. Here's what we think and how we can find out if it works. Experiment. After diverging on various ideas and weighing different options, the project's formed into a testable structure. Analyze. Review the results of the test, See if it was successful and what other questions came from the data. Report. Communicate the results of the process to any stakeholders. This information can be used to express the value of your solution, or it can be used to improve the process next time, because the next step is to rinse and repeat. Figure out if the solution is repeatable at scale and if you can further improve it. Here you can start back at observation, but the steps might be less linear and more recursive depending on the situation. Okay, let's look at some examples. We'll start with Gwyneth Paltrow's Goop. Just kidding, we'll look at Dyson. James Dyson observed that traditional vacuum cleaners lost suction when their bags became full. Applying the scientific method, he questioned whether there was a better way to maintain suction power. Dyson ideated and developed a hypothesis around cyclonic separation, a bagless vacuum technology. After creating numerous prototypes, he iterated on the design, refining it through testing and user feedback. Today, Dyson has knocked it out of the park with a range of products for various industries while applying similar learnings. He also happens to be the wealthiest industrial designer ever. So this is a clear formula. We should be able to automate it, right? I told you before, it's easy to do this backwards and look at the end result. No matter how sophisticated your automation tools get, the adage stays true. Garbage in, garbage out. There are aspects of this process that can be automated, but trying to apply it like a formula is usually when it goes wrong fastest. I've had clients literally ask me to make their products like Apple. They think we're going to go into a room and do some road mapping or run a design sprint and come out with something magical. The point of running a process like this is to start a cultural shift in an organization. It's great if we have deliverables at the end of a meeting, but the goal is really to give people these tools and a tangible example of how to use them in the future. As I mentioned, failure is inherent in this process. Additionally, the process can be very counterintuitive. This is especially important in the earlier, more divergent phases. A lot of the most groundbreaking solutions come from observations with a very disparate set of data points. Let's look at another example where things went wrong. Spencer Silver, a scientist at 3M, set out to create a new adhesive. Through the process, he ended up with something low-tack, less sticky. Art Fry, a 3M product developer, observed a need to keep bookmarks in place during a church choir practice. Fry and Silver prototyped an idea, developing the first iterations of what's now known as the Post-it note. Sometimes the process gives you information so you can try again, and sometimes it leads you to completely unexpected places. And you don't always need to run the process from start to finish on one monolithic product. Let's look at the current fastest growing product of all time, ChatGPT. OpenAI had a very powerful but technical product in Playground. In order to improve their AI systems, they needed usage and feedback from a broader set of users. Unfortunately, Playground requires a pretty technical understanding to use it. By thinking about UX and identifying a solid minimum viable product, they packaged their GPT model into a simple chatbot that anybody could interact with. Within weeks, its adoption surpassed the expectations of even their own team. So those examples should give you a sense that there's some fundamental concepts, but the application is different in every single one of them. There are a ton of levers to pull here, and all of them impact the outcome. Also keep in mind, this is a well-regarded, heavily adopted, and systematic approach, but it's not the only way. Some creative projects are born from the sheer will to create something, and others happen completely by accident. In the end, you can try to attribute success to the person most prominent in a project, but you might as well be trying to read tea leaves. For now, there's one consistent takeaway from all these success stories. People had an articulable problem, they tried stuff to solve it, and it was measurably successful. If you really want to be innovative, just try stuff. Use whatever tools you have available, and measure the success by whatever metrics make sense for you. If you happen to strike gold, people might ascribe all sorts of irrelevant things to you. In the end, it's just noise. If you want more on some of this phenomena and how it's affecting creative fields, check out my buddy John's video. He did some great stuff on this. Blah.